Now talking about, I think I'm getting some warmth here, so now I'm
Mm.
more confident. Okay, all right. Now we already covered about the execution plan, how exactly we'll be able to generate the execution plan, how it exactly they looks like, and talking about this last column time. So never ever rely on this one because it's just a, some heuristic based algorithm figure that I actually present. So never ever depend or bank on this specific figure. So if it's saying 0 0 0 1, so it's not the case like it's always go and do or spend the same amount of time. This could vary. Now about the execution plan, they actually comes in with different shapes and sizes. And saying different shapes and sizes, I mean, what we just saw is just the basic or the general execution plan. If you want to generate the extended or an advanced level of execution plan, there are few options available to you. So what we just saw, where the ID, operation, and name specific information is present, that's always called as a basic level execution plan. So if you want to generate an extended and advanced level of execution plan, so that is with rows and estimated rows and bytes and estimated bytes, temporary specification, cost, time, and an estimated time. So that is called as an advanced level of execution plan. And before that, and switch to the next slide and show you how exactly you will be able to generate the advanced level of execution plan. These are few important sections that you will see just below your execution plan. The very first is always the predicate information, which actually comes with the access and the filter path. And now talking about any idea, guys, what exactly is this filter and access? Anyone?
No.
No.
Predicates uh,
Mhm.
on which basis the column is filtered.
That's right. But what is the difference between the filter and access? So what exactly the filter represents and what the access term represents? So let me help you. Access predicates are those that are used to scan the index, right? So these predicates are used to select which branch and leaf blocks to retrieve from the index, and they are more important to the performance of the query. And talking about the next one, filter, right? Filters are what? Filters are again a kind of a predicates, and these are those that are applied to the rows returned from the index. So they determine which rows are ultimately sent up to the next step in the query execution plan. Okay, so that's the major difference in between the access and the filter type of predicates. Both of these are predicates, of course, but there is this is the main or the core difference in between these two. So talking about the outlines, like if you have generated usually you do not see the outline data specific information below your execution plan because this actually comes into the advanced level of execution plan. So if you have generated the advanced level of execution plan, then I'm sure that you will be you're familiar with this term outline data. So outline data is nothing, is just a minimum set or the representation of the hints that the optimizer has actually selected or prepared in order to bring up this final execution plan. So if you go and see, this is basically a set of hints that's actually using like optimizer underscore feature underscore enable, db underscore version, all underscore rows, right? Uh, and sometime you'll also see first underscore rows underscore one. Any idea like what exactly is this first underscore rows underscore one or this specific? Okay, maybe I'll ask this question later on. Now, few of the other hints that you are seeing here is index underscore rs underscore asc. So this is basically for range scan. Index underscore rs stands for range scan underscore asc is for ascending order, right? And full is for full table scan. Leading is for leading column. Use underscore hash is when it's preparing the hash for the execution plan, and that's it. That's the end of the outline data. So that's how the simple outline data looks like. As I told you, this is the bare minimum or the collection of the hints that was used by the optimizer to prepare this specific execution plan. All right. The section 4, the very last section of the advanced level or advanced execution plan you will see is the notes section, right? For example, if you are seeing my screen like SQL profile prof underscore fixed for this is used for this statement. For example, if you have applied or fixed this SQL using any SQL profile or anything of that sort, then in the notes section, you always have that information present, right? So that while doing the performance analysis, you will be able to understand, okay, there is already one plan that is fixed or was used to force some specific plan hash value for this SQL ID. Any question, any doubt?
Yes, so Prashant, I have doubt here. Actually,
Yep.
outline data. So before doing any analysis, so we have to initiate these commands, right?
No, again, Uh, if you feel like the general or the basic execution plan is not sufficient, it's not solving the purpose, and if you want to go deep into deep into it, and if you want to study what all outline data or in that kind of information was used by the optimizer, then yeah, of course, you should always go and generate the complete execution plan or the advanced level execution plan, which will provide you the outline data along with the predicate information in the node section.
No, actually, I have seen while the troubleshooting or
Mhm.
the different type of the ADDM report and analyze the tuning advisor.
Yeah.
I have checked that the cost actually I have seen their cost is low actually, but the table access is the full. So I just have the doubts. Actually, when we see the table access full in the
Mhm.
sort column, sort rows in the column, but still the showing of the full access path. So is there any something the plan or so what kind of actually the troubleshooting we can use in that case where we have seen the table access is going into the full scan into the smaller table where the rows is less and the cost is also less.
Mhm. Then what's the problem? I mean, you're saying like this query is going for a full table scan and this table is very small in size and the cost is also small. So this ideally this should come out very quickly, right? So you should not have
Yeah,
any
so
wait time, right?
yeah, so we need to the taken care of that why it is going to the full access scan and
Okay,
in
so
that case.
now I got your question. So your question is why it's always going for a full table scan, why it's not picking the index. Okay, this is a very classic problem, right? And in order to answer this question, though I have few more slides, but I think this is the right time. I should be able to break this myth. Like, is full table scan is always bad and index scans are always good? It's not the case. No. For example, imagine like you've got a table that has 100 rows, right? And out
Right,
of those 100 rows, right, if we talk about the uniqueness, so it only got two type of values. The one value in this column is 0 and another one is value 1, right? And
right,
value 0 has redundancy. I mean, 99% of the total rows out of this 100 is with value 0, right? And you've got only single unique value with a value 1. That means out of the 100 rows, 99 rows are with value 0 and only single row is with value 1, right? So now, for example, you are executing a command select all from EMP. Let's assume this table name is EMP and column is ID column, right? So select all from EMP uh, where ID equals to 0. Now considering the fact like out of those 100 rows, 99% of the rows are with value 0. So what will be the best access path here? Should it go with the index scan or with the full table scan? Question is for you.
Full table.
Full table scan, absolutely, right? Because there is no sense of going an index scan when this query has to has to prepare the result set of 99% of the total rows, right? So this is always a bad approach, like going for an index scan and then fetching almost everything from the table, right? So why to spend time when you have to return 99% of the total rows from this table, right? So in that scenario, when you are fetching the the low cardinality results, then of course full table is good and is best. Index scan will be worst. So the second scenario is like select all from EMP where ID equals to 1. And as you know, we have got good uniqueness. We have got one single value out of those 100 rows with a value 1. And now when you're doing select all from EMP where ID equals to 1, so this the best possible access path for this specific SQL is always index scan. It could be index range scan or whatever, depends on your SQL statement. But yeah, index scan will be the best access path here because in that case, You do not want to scan or traverse every possible rows that is present in that table, right? So because this value is unique, so if you have any index created for on this column ID, so it will go and use it, and your query will be fast. Okay,
Okay, fine. Thanks.
are you getting my
Yes, yes.
answer? Okay, so
Yeah.
again, it depends on the uniqueness or the NDV, in short called number of distinct values. More you have number of distinct values, you have less chances of query going for a full table scan. Again, it depends, a lot of scenarios that comes into the picture, but yeah, this is what it is. So it depends on the cardinality and selectivity of your table and
Yes, I
based
think,
on the SQL that you're pushing.
yes, Saket, I think we have been discussing, like good candidate for the index or bad candidate. So this is where like Prashant is insisting, okay, are we creating index on the column like which is really helpful or not? So cardinality, distinct values like, so these are the
Right.
basically parameter you can consider while, taking a decision for the index.
Absolutely. So if you feel like there is a very less uniqueness, then I think instead of creating index, you should always go and try with the histograms first, right? Because histograms are kind of an extended column statistics that provides some more stable performance. Because adding every time you face some problem and add a new index, so it's not a good approach in my opinion, right? You should always utilize and exhaust with other approaches and other strategies. If you are done with them and you do not have anything else to try, then of course go and do the indexing. Otherwise, there are a lot of other cool stuff available. Okay, now talking about the execution plan, this is how you actually generate the typical or the
Prashant sir,
base.
just one more thing in
Yeah,
related to
yeah, yeah.
the previous issue means the adaptive cursor sharing is also related to the same thing now that when the data is highly skewed and we are using the bind variables and the means the optimizer is confused either he needs to go for the full table scan or for the index scan because every time the query is using the bind variable.
Okay,
So
well, I think this is very early to answer your question because most of the other participants are, I think, not that confident if we talk about the adaptive cursor sharing. But again, I would like to answer your question only. So, talking about the adaptive cursor sharing, so that's this option is, I think, was first added into 11G, 11G 1 or 2, I'm not sure. But yeah, uh, what happened is like adaptive cursor sharing did not take effect and force the re-evaluation of the execution plans, right? So I mean to say the execution plan was not changed to a again, uh, explaining that thing at this point will be little little confusing for rest of the participants. So let's park this topic. Maybe on day 2 or day 3 I will be able to explain much, and you all of you guys will be able to explain and understand. Okay.
okay, sir.
Right. And what exactly is the importance of having ACS, or in short, what we call as an adaptive cursor sharing, right? And how dramatically it improves the performance if you're running on any version that is above 11G release 1. Okay.
Okay,
Now
sir.
talking about the
Sir,
display function. Yeah.
Prashant sir, I have a question. Means suppose there is a query and I
Mm.
want to generate execution plan multiple times. So suppose I generate execution plan today and yesterday I also generate execution plan of the same query. So
Mhm.
my question is that it will be the same or based on what it's means how it's generated basically.
Okay, a lot of things that actually comes into the picture here. It also depends on the cursor underscore sharing value that you are using, right? And also depends on the where clause. So for example, if you are doing for example, if you're changing your SQL grammar only in terms of your where clause, then of course you'll see a new SQL ID generated, right? And you have a different and altogether a new execution plan for it. So it depends, right? So most of the times it's the bind value that you are actually passing to your where statement, your where clause, right? So for example, if you are changing the entire logic of the SQL, so it could be the case like your the optimizer will prepare a new plan hash value for it, right? And you will see a new plan hash value will be adopted by the SQL ID, right? So what I'm saying is like same SQL ID, and right now it has two plan hash values. But now when you change the bind variable value, so ultimately that's an optimizer is considering as a total change or a complete change to this SQL logic. So what it will do, it will generate a new plan hash value, hash value for it, and it will be used by the SQL ID. And it could be a case like you'll see a separate or altogether a brand new execution plan or a plan hash value for your SQL ID. Getting my point?
Okay, okay. Means same SQL query gives the same SQL hash value. Am I right?
SQL ID can have multiple plan hash values. Okay,
Okay.
let's take an example. You are doing the select all from EMP where ID equals to 40, right? Next day you are using same SQL but replacing your bind value is value 1000, right? So again, it will now depend on the repetitions or the uniqueness or the cardinality of your columns where you are actually calling the where clause, right? And for example, this value now you're passing 1000, and it is a right candidate for a full table scan, right? So automatically you will see a change. You will get a new plan hash value generated or an incarnated for the SQL ID and will be picked or will be opted by the by the optimizer, right? So maybe a case like last day you have executed this query with a different bind value like ID equals to 30, and it was using an index range scan. But now when you have changed the same SQL ID with the ID equals to 1000, it's now started doing the full table scan or maybe an index skip scan or indexed fast full scan or anything else, right? And for that you'll see a new plan hash value has been generated, right?
Okay. Got it now. Yeah. Thanks.
Okay, so that's how you generate the general or the basic execution plan using typical function, right? And the another way how you'll generate the advanced level execution plan is using advanced uh, into the DBMS underscore explainer display function, right? Now, let's spend some time to study about the execution plan, how you actually interpret them, how you break them in order to understand the behavior of the performance. So basically, if you are familiar with the B tree structure, where you have a parent node and you have leaf blocks and you have branch blocks, right? So same structure or analogy actually applies in the case of execution plans too, right? For example, if you're seeing this execution plan on the right of the screen, right, you see you have an update statement, right, and you have some kind of indentation or a flow that's happening from top to bottom. Are you seeing that flow or indentation?
Yes,
Like
sir.
in the let's see, I mean, if I draw a line, an imaginary line from U, this alphabet U, you will see most of the operations are actually going uh, bottom to it, right, on the right. So that's
Right.
why we have a parent ID that is called as a zero, right? So zero ID. I mean, within your execution plan, the ID 0 will be the parent here. If I draw an imaginary B tree index for this execution plan, I mean not B tree index, I mean B tree kind of a structure, then this will always come at the top with a value 0. And then uh, if you see the indentation, we have next update. So do you see anything that comes with the same level of update? No, right? Or yes?
No,
Can someone please tell me?
no, sir.
No?
Sort aggregate.
Sort aggregate. That's right. Yes. But again, my question is something else. Do you see anything that is coming in the same indentation? Actually not, right? Only the update is the next uh, node, because there is no one in rest of the operations which is coming in the same flow or the same indentation, right? But if you check update now, you'll see a nested loop coming, right? Just underneath update statement. So nested loop will now become, I mean, ID2 will now become the new child of this node 1, right? And now talking about the nested loop, we have got table access full and index unique scan at the same indentation or the same level, right? That means nested loop will have these two child operations. So nested loop is what? ID number 2, and table accessful is what? ID 3. It will become child of this, and index unique scan is ID 4. again this will become a child of this parent node 2, right? So nested loop is little bit on its left, and these two are there at the same level, right? No change in the indentation, correct? Or the formatting,
Right.
right? Next comes, that is at the same level of nested loop, is the sort aggregate 5. So it will become the next child of this parent 1, right? Update, first parent was nested loop, second parent now is sort aggregate. Sort aggregate is the next child. Now if you check the sort aggregate, it has a next child table access by index row ID. So ID 6 will become a new child of this parent 5. And if you check the next operation or the access path, it's there for index full scan, right? Again, there is a little change in the indentation. That means this will finally become the child of this operation 6. So we have a new uh, node added, right? S7 for 6. Next is the table access by index row ID, and both nested loops, sort aggregate, and operation at ID8, table access by index row ID, are at the same level or the same indentation or a flow. So now that means this update statement, this parent ID1 has got a new child 8, right? So this is the child 8 for this. And if you talk about ID or the operation sitting at the ID number 8, we have got a new child index unique scan, right? So that's how. So this is how you actually prepare a kind of a hypothetical or an imaginary B tree kind of an index, or a B tree kind of a structure basically, right? Where you have few parent nodes and few child nodes and few working node or leaf nodes, right? So for example, it will always start with the child, with the leaf blocks 3, 4, 7, 9. That means ID or operation sitting at ID number 3, 4, 7, 8 will be the very first one which will do the work and will pass on their results or inputs to their parent, right? So 7 will let's understand 7 first. So 7 is what? It's actually doing an index full scan. By the way, do you know what is index full scan? Anyone would like to answer this? Index full scan.
Reading the complete index.
Complete indexes, row by rows.
Mhm. Well, talking about the uh, index full scan or full index scan, basically the database reads the entire index in order, right? So a full index scan is available if the predicate or the where clause in the SQL statement references a column in the index, and in some circumstances when no predicate is specified, right? So that is what a clear explanation about the full index scan. So basically, uh, everything that you want to select from the table, it's also available within the index as well. So it will go and do the full scan of that index. It will be little faster as compared to the full table scan, but it almost same. You'll see a negligible difference between the two. So if you're seeing an operation called as index full scan, and so treat it like a full table scan, because ultimately there will be marginal difference between the of the cost between the two. I mean, doing a full table scan and doing an index full scan, because ultimately index scan is what? Index is what? It's the exact replica of your table, right? So everything that you have in your table is present in your index. So if you're doing an entire scan or a full scan of an index, ultimately you're scanning each and everything that's also available in the table, right? It's just the case, like, because it's a B tree kind of a structure, things will be little faster, but that difference is very minute or marginal. You hardly see any difference, noticeable difference. Okay. Any
Okay.
questions?
So means the optimizer will read the seventh ID first, and then it will go for 3, 4, and 6, 9. Is
No,
it?
no, 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 no. Again, I was just picking one example. Like, flow will be always from the last, ninth, right? So that means first the index unique scan will happen, right, on this primary key, index t underscore pk, right? And once it get the desired number of rows or the row set, it will pass on that to operation 8 or the ID number 8, because that is the parent of operation 9, right? So ultimately it will pass on the result set to table access by index or ID on this table T. So ultimately this operation at 8 and 9 is now finished. They will finally push the result back to 1. That is this update statement. But we have other operations as well, right? So 7 will do its work. I mean, it will do the index full scan on index I, right? And it will pass on the result set to its parent table accessed by index row ID, right, on table T. And ultimately what will happen? A sort will happen here. A sort aggregation will happen here at point number 5, because point number 5 is parent of both 6 and 7, right? So 6 and 7 will pass on the result set to sort aggregate. That's where the sorting operation will happen and temporary area will be used, right? And talking about this one here, the leaf node 3 and 4 will do its work. I mean, they will do things in parallel, doing an index unique scan and table access full. It will read everything from this table T, and it will apply a uniqueness on this table using T underscore PK primary key, and then the result set will be passed on to the parent operation, that is an NL or the nested loop operation, right? And ultimately, when all of these operations sitting at 2, 5, 8, 2 nested loop, sort aggregate, and table access by index row ID is finished, they will pass on the result to their parent 1. 1 is the update, and finally 0 is the super parent. So everything will be finally applied by using the update statement. That's it.